Okay, so today's lesson is going to be naming transition metals. So group 1 and group 2, aluminum, and then cadmium, zinc, and silver are the binaries that already know the charges, where when we start to deal with that D block, or the transition metals, we already talked about the fact that those metals may lose different amounts of electrons depending on what they're bonded to. Okay? So let's just remember a couple of things. When I'm writing a formula, I need to make sure that the positive charges cancel out the negative charges. Okay? So this is done by this simple equation. Okay? So how many times the charge plus how many, so how many of that anion do I have, times the charge, that has to equal 0. Okay? So we can use this equation to figure out transition metals charges to then name them. Okay? So this is one way of doing it, and then I can show you another easy way, but we have to remember that ultimately our goal is to have a charge of 0 on the ionic compound. Okay. So binary ionic compound. So we're still talking about two elements inside of a compound, a cation and an anion, and this time we're going to use transition metals. So these are our D block metals and some P block metals that are going to be considered transition or binary in a binary transition compound. So all of these are going to be considered wishy-washy, meaning their charges can vary depending on what they're bonded to. So I'm going to say that these are wishy-washy elements. Except for, and this is what I talked about on the last lecture, silver will always be +1, zinc will always be +2, and cadmium will always be +2. So I need you to make sure that you have those three memorized outside of group 1, group 2, and aluminum. Okay? So the rest of them need some sort of identification in order for us to know what charge it is. And we're going to use a Roman numeral. Okay? So let me just do a quick refresher so you know what a Roman numeral is, because sometimes I don't think you probably have seen this since elementary school. So this would indicate 1, this would indicate 2, this would indicate 3, and then IV is your 4, and then V is 5. We tend to not go above 5, but in case you do, you would just continue to add an I past V up into 8, and then you would do IX for 9, but we don't get to that far. Okay? Alright, so to find the formula from the name, it's actually pretty easy because the Roman numeral tells us the charge of the transition metal, okay? And then the anions are easy to find because that's going to be most of the time group 15, group 16, or group 17. Okay, so let's look at a couple of examples here. So iron 3 chloride. Okay, so binary chlorine just means that it's, or chloride just means that it's Cl. So I'd off the periodic table. Okay, so iron is going to have a +3 charge, where chlorine has a -1 charge because it's in group 17. Okay, now just like we did with the known charges, we ask ourselves, do the charges cancel? If the answer is no, we have to crisscross them and make them subscripts for the other element. Okay, so I'm going to give the 1 to iron and the 3 to chlorine. Okay, so this formula will look like this: Fe1Cl3, which means that iron is losing 3 electrons, but chlorine can only gain 1, which means I'm going to have 3 chlorine atoms in order to accept all 3 of iron's electrons. Okay, let's look at another one. Copper 1 oxide. Okay, so the 1 goes with copper. It's telling me what its charge is. So it's copper +1, and then oxide or oxygen, which is in group 16. So it's going to be O -2. Do the charges cancel? The answer is no. Therefore, they must crisscross. So this will be Cu2O. Copper 1 oxide. Now you need to make sure that I say 1 when I name it, because that 1 is specific to copper's charge. Okay. Alright, so that's how we would write the formula from the name. what would it look like to write the name from the formula? Okay, and this is where this little equation is going to come from. And I'm going to show you two different ways to do this. Okay, so we need to have the concept that the charges cancel out like we did before. Okay, so our formula that we're going to try and name here, so I'm trying to figure out what lead's charge is so I can write it as a Roman numeral in the name. Okay, so I'm going to ask myself, how many cations do I have? And the answer is 1. My question mark is I'm trying to figure out what the charge of lead is, and I'm going to add that to 1 oxygen times its charge, which is -2, and I need to get it to equal 0 because the charges have to cancel out. Therefore, mathematically, if I solve for the question mark algebraically, I should get my question mark minus 2 is equal to 0. And then if I add 2 to both sides, my question mark will become plus 2. So this indicates that lead's charge is plus 2. Therefore, I'll name this lead 2 oxide. Okay? Let's do another one. So the next one is iron 2 Fe2. I'm sorry, I just made a mistake. Fe2O3. Okay. So let's do it the first way that I showed you. So how many cations do I have? I have 2 of them. Okay, I have 2 irons. I'm trying to figure out what its charge is. Okay, and that's going to be plus, I have 3 oxygens times its charge, which is -2, and that all needs to equal 0. Okay, so this is going to be 2x minus 6 is equal to 0. Okay, I need to add 6 to both sides, so I'll do plus 6 plus 6. So this will be 2x is equal to positive 6, and then divide both sides by 2. So x is going to be equal to plus 3. Oops, I'm sorry, you can't see what I'm doing. So x is going to be equal to plus 3. So therefore, iron's charge is plus 3. So to name this, it would be iron 3 oxide. Okay. Now that's one way of doing it. Now with our lead 2 oxide, the example or the thing that I'm going to show you right now might not necessarily doesn't necessarily work for that. So, but this is kind of a more simplistic way of thinking about this. As you can say to yourself, if we crisscross to get the formula, shouldn't I be able to uncrisscross to get the charges of the transition metal? In most cases, the answer is yes, okay? But you always need to ask yourself, when I uncrisscross, is the ion's charge what it is supposed to be, okay? So for this iron 2 example, if I uncrisscross their subscripts, so oxygen will then have a -2, and iron has a plus 3. So I always need to ask myself, is oxygen's charge -2? The answer to that question is yes, therefore iron's charge is going to be plus 3. Okay? Now we need to be careful though when we do that, if you're going to use that as a way to solve these problems. For this example, so if I write this out bigger, there's no subscripts here which indicate 1 and 1. So if I uncrisscross here, I need to ask myself, is oxygen's charge -1? The answer in this case is no, okay? Oxygen is -2. Therefore, if there is no 2 here, like there should be, that must mean that the charge is canceled. Therefore, lead's charge would be +2 and oxygen's charge would be -2, which means they would cancel and make PbO. Okay, so that's one way. Let me do a couple of examples here with you really fast. I'll just do these first 2, and then you can do the rest by yourself. So I have tin 4 nitride. Okay, so I'm going to write tin is SN, has a +4 charge. Nitrogen is in group 15, which means it's going to gain 3 electrons, which is -3. Charges don't cancel, therefore I'm going to crisscross them, so nitrogen or tin gets the 3, nitrogen gets the 4. Therefore, this would be tin, 3, and 4. So tin, 4 nitride. Okay? All right, let's look at the next one. Okay, I'm going to do my mathematical equation here. So I have 1 cation times X, which I'm looking for its charge, plus 2 oxygens times -2, and that all needs to equal 0. Okay, so this is going to be X minus 4 is equal to 0. So X is going to be equal to +4. Therefore, manganese's charge is going to be 4. So I'm going to write this as manganese 4 oxide. Okay. Now this would be one of those examples where the uncrisscrossing wouldn't work, and you would have to do the math to figure out what the charge would be. So go ahead and try the rest of those, and make sure you write down questions if you have them.